Good morning, my name is Elton Domnori. The title of my thesis is Environment for Intelligent Scenarios and Agent-Based and Semantic Approach. My supervisor is Professor Letizia Leonardi and co-tutor Engineer Francesco Guerra. Last year, my research activity was focused on the application of software agents in the healthcare system, and in particular in the management of territorial emergencies. The activities is divided into these 5 steps. The first step was the analysis of the state of art of the application of software agents in the healthcare system. During this period, I didn't find any exhaustive work of on the management of emergencies. I analyzed the feasibility of the application of Java technology and the Jade platform to afford our requirements. The third step was the design of the architecture of the UbiMedic 2, followed by the development of the framework. And the last step was some performed of testing. The motivation of using the support technology to the management of emergencies is the weak points that the current approach have. Some of these weak points are communications. This approach, the current approach is a centralized approach. There is one operative center that communicates with all the units and try to organize all the units in the operations. Each unit must communicate with the operative center. The operative center makes available only one phone line and only one radio channel to communicate, and the number of communication is very high, so this becomes a real bottleneck. There is no way to make broadcast communication or multicast communication. There is no decision-making support. The human operator must decide how to use all the units, and when these units that can be ambulances, helicopters, medical cars, when this number is very high, the decision is very complex, and actually there is no support to this decision. There is no data storage. All information collected, even about patients, are stored in papers and exchanged among medical staff, but no digital information is taken, and this leads to no statistics, which are necessary. UbiMedic 2 is developed totally in Java, which makes it portable to all the platforms. I used the Jade platform. Jade stands for Java Agent Development Platform. Jade is very used in and is supported from all the operating systems. And its strong point is that it's supported even on smartphones like Android. To develop this framework, I used the BDI technology. BDI stands for Beliefs, Desires, Intentions. This is the architecture to develop with agents. This is the most feasible architecture in our case. Beliefs represent the information that agents have from the environment. Desires, the task, and intentions are the set of actions that the agent must undertake to reach its task. This is the architecture, considering the units involved in the rescue operation. We have service agents that are the most simple agents in our architecture. They present devices. They use the client-server approach because they collect information from the device and make them available to other agents. They are divided in 2 subcategories. Device service agent that represents medical device. They just collect information and make them available. Client service agent that are installed in PDI or smartphones or personal computers. These devices are used by medical staff to insert some other information about the patient, like personal information, health information, and this agent collects information from other devices, medical devices, and make them available to the medical staff. Another category is the operative agent. These are more complex agents. They have decision making. They are divided in mobile operative agents and the stationary operative agent. The first are represent units like ambulances, cars, and helicopters because they are mobile units. And the stationary operative agents represents hospital, temporary camps for long treatment patients. The activator interfaces with human operator in the operative center. It receives all the new requests for intervention and dispatch this request to the operative agents. Operative agents have some decision logic. They collect information from devices, they coordinate with each other, and decide where to send the patient and their pathology. This is a representation of the architecture, and we see that MOA, it's a mobile operative agent that usually is represented from ambulances. DSA, the digital service agent, that is ACG or an oximeter, a client service agent that can be a PDI or a smartphone, stationary service agent, operative agent that can be an hospital. The activator is the operative center. To perform some tests, I developed a set of agents and their interfaces. Some of the agents are the ambulance agent, that is a specialization of a mobile operative agent. There are classes that inherits from the architecture class, MOA. Agents usually have their own state. No mouse. Has GPS coordinates that here are for testing are represented just as coordinate X and Y. The service is the operation that an activator sends to the ambulance, and is expressed in address, in the main pathology, in a gravity code. Destination, in the destination we can see the decision that the ambulance take where to send the patient after the evaluation. Some of other agents implemented are the ACG and the oximeter agent. They simulate the medical device. They have their own interface where the user can insert some data. And by changing this data, they can control how the ambulance change its decision based on the information of the patient. It's a PDI agent that is a specialization of client service agent. This is an agent used by medical staff, and it has its own interface. Medical staff can insert personal information about the patient, like name, surname, birth date. Can insert some health information because devices, there are no many digital devices available. So many of the information are given from the medical staff. And using this agent and this interface, the medical staff can visualize information collected from other devices, and like ACG, ACG trace, the oximeter. This is a scheme of the process. The activator asks to a mobile operative agent if it is available for a new intervention. If the mobile operative agent responds with OK, the activator sends all the necessary information to reach the place and the main pathology. The mobile operative agent receives from the device service agent or the client service agent continuously information which stores them in a database, and continuously makes some health evaluation. This evaluation, based on the information collected, can change, and so can change even the decision of the ambulance where to send the patient. If the gravity, the seriousness code of the patient is low, it can decide the most proper department or hospital. If the seriousness of the patient health is high, it can decide the closest one. And this logic can be changed, but the architecture remains the same. The mobile operative agents communicate with stationary operative agents, that is usually hospital or temporary camp, send a request to host a patient, and waits the response of the stationary operative agent if it accepts or refuses to host this patient based on his capabilities and the number of maximum patients that can hold. As future work, I intended to integrate this architecture with the PIM technology. The PIM technology is a process that moves from one node to another, coordinating them. This allows to decrease the number of communications between agents and to enclose the logic, the decision logic, in a single process. This process can decide the dispatch of the intervention and the dispatch of patient. Another field in the future work is the implementation of some smartphones, particularly using Androids which give support to JADE, and make available multi-agent application on smartphones. These are my publications, some submitted ones. Thanks you for your attention. If there are any questions.